The idea of an apocalyptic event, where the fate of our planet hangs by a thread, is not a new concept. For centuries, mankind has looked to the skies and wondered about the possibility of a catastrophic event from the cosmos, be it from a comet, asteroid, or some other celestial object. In recent years, however, the threat has become all too real. As we peer into the vastness of space, we come to understand that Earth is vulnerable to objects from beyond. But what happens when we learn that one of these objects is heading directly toward us? The threat is no longer fictional, and the situation is far more serious than most people realize. Imagine a situation where the countdown has begun, and humanity faces a very real threat, an asteroid named Apus, approaching Earth in a celestial dance that could result in disaster. A rare celestial event, Apus' approach has caught the attention of scientists, and the danger it poses is not something to be taken lightly. NASA's latest study has revealed a sobering reality. Our planetary defense systems against objects from space are still in their infancy, and should a true emergency arise, we would be hard-pressed to prevent disaster. The truth is that, while we have made some strides in studying and understanding these cosmic threats, the technology to protect Earth from such an impact is not yet fully developed. Apus, with its ominous name derived from the Egyptian god of destruction and chaos, represents a looming cosmic threat that scientists are now closely monitoring. The asteroid's presence in our sky has drawn comparisons to the very gods of destruction that ancient civilizations feared, but in reality, Apus is a natural, predictable object in space that could still cause destruction through the force of its size and velocity. Despite its name, Apus isn't trying to destroy us, it's just following its orbit. However, its approach to Earth and the potential for a catastrophic collision means we must take it seriously. Asteroids like Apus are not the result of malicious intent from some cosmic force, they are simply celestial bodies that are influenced by the laws of physics and gravity, drifting through the solar system along their preordained paths. In Apus' case, the asteroid is following an orbit that, while predictable, brings it dangerously close to Earth in the coming years. The problem isn't that the asteroid has malicious intentions, but that it might impact Earth in a way that would change the course of life on this planet forever. The reality is, despite the asteroid's lack of agency or will, the damage it could inflict is very real. Scientists have been aware of Apus since its discovery in 2004. While the media was preoccupied with other global disasters, such as the 2004 Asian tsunami, the discovery of Apus raised eyebrows in the scientific community. At the time, NASA warned that the asteroid's trajectory might put it on a collision course with Earth by 2029, but those early estimates showed a small probability of impact, about 2.7%. The asteroid's exact path was still unclear, but that small chance was enough to worry scientists. Unfortunately, with the media's attention elsewhere, the discovery went largely unnoticed by the general public. NASA retracted the warning after refining its calculations and updated its prediction, which eased the concern for a while. As time passed, however, the potential threat from Apus returned to the forefront. The asteroid's trajectory was revisited after a series of significant flybys and new discoveries. Apus continued to orbit the Earth like an ever-present cosmic fly, and while the immediate threat of an impact in 2029 had been largely alleviated, the possibility remained that it could strike in 2036. The asteroid's proximity to Earth makes it a subject of constant study by astronomers, and the closer it gets, the more important it becomes to understand its behavior. Apus, with its unusual peanut-like shape, is particularly difficult to analyze and track with the tools currently available. Most asteroids are relatively spherical in shape, which makes predicting their motion easier. However, Apus' irregular form presents challenges for scientists who need to accurately track its trajectory. Asteroids like Apus often have a history of colliding with other bodies in space, resulting in their unique shapes. This irregularity in shape is one of the reasons why Apus' rotational dynamics are so important. When an asteroid has a shape like Apus, it doesn't rotate in the typical way. Instead, the rotation is influenced by the asteroid's mass distribution, and in Apus' case, this causes what scientists refer to as sloshing. This sloshing effect, which refers to the uneven distribution of mass and the resulting irregular rotation, can cause significant variations in the asteroid's orbit over time. Essentially, the way Apus rotates can lead to changes in its trajectory that are difficult to predict. The further an object like Apus gets from its original path, the more unpredictable its movement becomes. This is where the Juravsky effect comes into play. The Juravsky effect occurs when heat emitted from an asteroid's surface becomes asymmetric. As Apus rotates, it absorbs heat from the sun during the day, and at night, it radiates this heat back into space as infrared radiation. However, the shape of the asteroid means that the radiation isn't distributed evenly, and this creates a small but continuous force on the asteroid. This force, while tiny, can accumulate over time and change the orbit of the asteroid. The effect is subtle but significant. Over time, this gradual change in the asteroid's orbit could cause it to deviate from its expected path, making it more difficult for scientists to predict whether Apus will collide with Earth in the future. Understanding the Juravsky effect and its impact on Apus is crucial for developing strategies to prevent a potential collision. With this knowledge, scientists are working to develop the technology to adjust the trajectory of asteroids like Apus before they pose a direct threat to Earth. To make such a maneuver, however, it's important to understand the physical characteristics of the asteroid itself. Apus is believed to be composed mostly of silicate rock, which has important implications for how the asteroid would react to external forces. For example, when scientists tested the concept of altering an asteroid's orbit with the Double Asteroid Redirection Test (DART) mission, the success of that experiment showed that it is possible to push an asteroid off course using kinetic force. DART was a proof of concept that demonstrated how a probe could deflect an asteroid, but Apus is far larger and more complex than the smaller bodies involved in the DART mission. Understanding Apus composition and its behavior in space is essential for determining how to divert it, should the need arise. The stakes are high. Apus is expected to come within 31,000 kilometers of Earth in 2029, a distance closer than any geostationary satellite. While there's no immediate risk of collision, this flyby could alter the asteroid's orbit in ways that make future encounters with Earth more dangerous. If Apus passes through a specific gravitational region known as the gravitational keyhole, its trajectory could be significantly altered, bringing it into a collision course with Earth in 2036. If this happens, we would have only 7 years to prepare. This scenario highlights the need for immediate and sustained efforts to protect the Earth from asteroid impacts. It is clear that humanity is not ready for such an eventuality. The problem is that even with advanced space exploration missions like DART, which proved successful in deflecting a smaller asteroid, we are still lacking the kind of planetary defense that would be required to deal with an asteroid of Apus size. The technology and methods available today simply aren't advanced enough to guarantee that we could prevent a catastrophe if the asteroid were on a collision course with Earth. What's more, there are significant gaps in the global communication networks that would be necessary to coordinate an effective response in the event of an asteroid threat. Scientists and government agencies are aware of these gaps, and NASA has conducted simulations to understand how an asteroid impact scenario might unfold. The results of these simulations are concerning. While there are some defense strategies in place, they are far from foolproof. In order to be truly prepared, the global community needs to invest more resources into planetary defense. The key lies in developing better technology to study asteroids like Apus, as well as improving the ability to deflect them. NASA's OSIRIS-REx mission, for example, which studied the asteroid Bennu up close and collected samples from its surface, is an important step in gathering information about asteroid composition. This data could help inform future efforts to deflect larger asteroids. Now, with the asteroid Apus on the radar, NASA is transforming the OSIRIS-REx spacecraft into OSIRIS-APEX, a new mission aimed at studying Apus and gathering more detailed data. This mission is critical to understanding the asteroid's properties and determining how we might be able to alter its trajectory if it becomes a threat. But even with these advances, the task of defending the Earth from an asteroid impact remains daunting. As Apus makes its way closer to Earth, scientists will continue to monitor its orbit and physical properties. This will provide valuable information that could help us prepare for a possible collision. However, time is running out. If Apus follows a path that brings it into contact with Earth in 2036, we will need to act quickly. Fortunately, the advancements made through the DART mission and other space probes provide hope that we can one day develop the technology to protect the planet. But this requires more than just scientific knowledge. It will take a global effort to ensure that we have the necessary resources and cooperation to protect Earth from cosmic threats. As we look to the future, the reality of space threats like Apus serves as a stark reminder of how vulnerable our planet really is. We have only scratched the surface when it comes to asteroid defense, and the time to act is now. With the right combination of technology, international collaboration, and scientific innovation, we may one day have the tools to divert asteroids like Apus and ensure that humanity is protected from the potentially devastating consequences of a cosmic collision. Until then, we can only wait and watch as this celestial force looms closer, hoping that we are ready when the time comes. It's a reminder that the universe is vast and unpredictable, and the Earth's survival may depend on our ability to adapt to the forces of nature that exist beyond our understanding. The clock is ticking, and the question remains, are we ready to face the cosmic destruction that may come our way?